Large language models are inherently conversational. They want to chat. But when you try to hook that unstructured, fluid natural language into strict, multi-stage autonomous AI pipelines, the process breaks down. You cannot talk to a hard-coded API and expect it to execute a 20-step workflow reliably. If you feed a conversational prompt directly into a rigid execution matrix, the intent ricochets off the logic walls. The system fails because it doesn't know how to route the request without a human hand-holding it through brittle code. The Orion Collective System solves this routing problem by bypassing the model's chat interface entirely at the orchestration layer. Instead, it relies on a mechanism called dense packing, located inside the YAML metadata of the system's available skills. By embedding specific keywords and scenarios directly into a skill's file headers, the system creates an automated, transparent bridge. The infrastructure actively scans your natural language input, matches it to the metadata, and instantly knows which multi-agent playbook to wake up. This strategy moves the orchestration challenge away from building larger, centralized routing models and toward the specific constraints of the metadata layer. Every available skill in the system has a header, or frontmatter, that tells the system what the skill does. We call the approach to writing this header dense packing. Instead of creating separate, complex arrays of tags, the developer injects all of the activation conditions, the exact what and when the skill should fire, directly into the description line of that file. To trace exactly how this payload moves, we can look at a specific skill called CodeGen Visual Meta. This is a playbook designed to generate executable code alongside matching architectural diagrams. Look at this code block. This is the YAML frontmatter for that skill. The description field is filled with specific conversational triggers, like UI mockup with implementation or architecture visualization. But the parser reading this file is mechanical. To ensure it loads the playbook without throwing an error, the entire description must be formatted as a single-line plain YAML scalar. It is one single, unbroken line of text. Furthermore, the text must completely avoid quotation marks, colon-space sequences, and angle brackets. A single stray colon breaks the parser, causing the skill to silently fail. When a user types a prompt asking to generate code and diagram, the infrastructure scans the system, spots that exact substring inside the scalar string, and automatically pulls the skill into active memory. These strict formatting rules are mechanical necessities. They guarantee the meta infrastructure parses and matches user intent with zero fatal errors. Activating the skill is only the first step. Once the orchestrator loads the playbook, it does not simply hand the user's prompt to a single AI model and wait for an answer. Instead, the system deconstructs that single conversational intent and distributes it across 3 distinct, interconnected, glowing execution nodes. This architecture is the 3-agent core. It operates as the persistent cognitive foundation for every complex workflow inside the Orion Collective System. This diagram illustrates the layout. The central orchestrator establishes strict connections, routing task parameters outward to the 3 primary actors: KickForge, KickFlow, and KickGuard. The first node is KickForge. Its job is task extraction and purification. It ingests the messy human prompt, isolates the actionable objectives, and verifies that the core request actually makes logical sense. Next is KickFlow. This node takes those purified objectives, figures out exactly what needs to happen first, second, and third, and sequences the work onto a linear timeline for specialized subagents. Finally, KickGuard stands as the perimeter. It monitors system integrity, enforces ethical compliance, and acts as a hard consent gate, evaluating every proposed action before any code executes. Standardizing execution into this triad ensures every single task is automatically parsed, intelligently sequenced, and ethically bounded. No custom routing scripts are required. The language coordinating the movement of data between these 3 nodes is a domain-specific language called KickLang. Before mapping the data flow, we must establish a core principle of the system. The roles within KickLang are not fixed pieces of software. They are dynamic cognitive stances adopted by the AI to perform specific types of logic. This diagram maps the canonical payload progression protocol. Data flows through strict namespaces, beginning with a raw packet identified as the object payload, or data/obj. In stage 1, KickForge ingests this object payload, the user's initial intent, and breaks it apart into raw, task-agnostic steps, labeled as data/tasks.
In Stage 2, KickForge subjects those raw tasks to policy constraints. Any step violating system rules is rejected. The surviving, approved tasks upgrade to purified status, becoming data/P tasks. By Stages 3 and 4, KickFlow takes over. It translates the purified tasks into an executable pipeline structure, the data/spec matrix, while simultaneously generating an active execution state so the orchestrator tracks the progress. This strict progression forces the unstructured prompt through a logical gauntlet. The step-by-step transformation creates a mathematical chain of custody, ensuring the final output matches the original input. To see how this architecture handles real complexity, we return to the practical execution of the CodeGen visual metascale. Building an application while designing its UI requires distinct logic. The system has to separate structural code execution from visual asset rendering, running both branches in parallel. This flowchart illustrates Stage 11 of the playbook. A strict logic gate evaluates the environment. If the system reads a flag confirming visuals are required, the pipeline fractures into a code branch and a visual branch. KickGuard oversees this split, explicitly delegating the visual branch to a specialized image generation agent known as AR00L. AR00L is mandated to generate architecture diagrams or UI mockups. It must parse the exact same specification data as the coding agents to ensure its visual output aligns semantically with the application logic. The infrastructure processes two disparate forms of data: rigid syntactical code structures and fluid visual compositions, perfectly merging them along a shared timeline. At Stage 19 of the meta playbook, the central orchestrator steps back in. It synthesizes the code artifacts, the UI mockups, and the ethical compliance tokens into a coherent final draft. Because the system handles the delegation in parallel, a single conversational prompt safely coordinates highly distinct agentic domains simultaneously. We have traced the payload from chaotic natural language through the dense packing of a YAML trigger, across the 3-agent core, and down the KickLang pipeline. This is the full-stack architecture of the Orion Collective System operating as a unified whole. It replaces brittle, monolithic API routing with a decentralized, auto-discovering ecosystem. It demonstrates how a tiny, precisely formatted input acts as the essential catalyst for a massive, automated systemic response. The strict formatting of a plain YAML scalar provides the semantic bridge necessary to authorize rigorous, ethically gated AI orchestration.